In this video, we are going to learn more on the elements, compounds, chemical equations, and calculations. Before we proceed further with this topic, we have to understand first the term given here. For example, we have atom. What is atom? Atom is a neutral particle made from proton, neutron, and electron. An example here we have iron, titanium, oxygen, aluminum, and sulfur. Then what is meant by element? An element is a pure substance that cannot be easily broken down into other substance by any chemical reactions. Example here we have chlorine, iron, lead, nitrogen gas, oxygen gas, and chlorine gas. Then what is meant by molecule or compound? These are the neutral particles made from combination of the same or different atoms. For example, here we have oxygen gas, hydrogen gas, water molecule, as well as ammonia. Lastly, what is meant by ions? Ions are charged entity with one atom or group of atoms. The negative ions is gaining electrons, so we call this as an ion. The positive ion is losing electrons, so we call this as cation. And for monoatomic ion here we have mono. The word mono means that we have one atom with charge. So here we have lead 2 plus, we have a chlorine minus, and Na plus. And for polyatomic ion, meaning that the atom having more than one atom with charge. So here we have hydroxide ions, ammonium ions, and cyanide ions. Okay, let's take a look at the detail about atom. Okay, atom is made from a nucleus here. Okay, at the center of the atom, we call this as nucleus, and the nucleus consists of proton and neutron. Okay, proton is a positive charge, neutron is a neutral charge, and the nucleus is surrounded by orbital, and the orbital is filled by the electron. Okay. And if you can see from the periodic table, okay, this is how we write the mass number or atomic number of an element. Okay, this one is the atomic symbol for an element, and A is represent the mass number, and Z is represent the atomic number. What is meant by mass number? Mass number is actually the total number of protons and neutrons in the atoms, while the atomic number is actually the number of protons in the nucleus of an atom. Please bear in mind that the number of protons is equal to number of electrons. And isotope here is meant by atoms with the same atomic numbers but different mass numbers, and a similar chemistry, forming a same type of compound and displaying similar activities. Example here we have 4 different types of carbon with the same atomic number but different mass number. Basically, there are 2 types of compounds that we are going to learn in this topic, and the first one is the ionic compounds. Okay, what is meant by ionic compounds? Ionic compound consists of cationics and anionics that held together by electrostatic attraction. And the ionic compound is made from monoatomic ions or polyatomic ions, and this compound also is made from metal and non-metal element by transferring or accepting the electrons. So here we have the example. When the sodium plus is releasing the electron, it requires the energy to release the electrons, and when the chloride ion is accepting the electron, it will release the energy, and when the 2 atoms combine together, it will release the energy to form the ionic bonds or the ionic compounds, and the energy release is in the form of heat. And the next one is the covalent compound. Okay, what is meant by covalent compound? Having 2 different non-metal elements that is bonded together by sharing electrons. So here we have the example of hydrogen gas, where the electron, or the 1 electron from each atom, is shared by each other. So now I'm going to show you how to write or to get the correct ionic compound formula by using crossover rule. Okay, example here we have aluminium 3 plus and oxygen 2 minus. Please bear in mind that in order for us to form the ionic compound, we have to have metal and non-metal. Okay, so to write the formula, we have to crisscross the charge, and we get the charge for O2 minus, we put it on the aluminium, and the charge on aluminium, we put it on the oxygen atom. So we get the formula here as Al2O3. So another example here, we have Mn4 plus as the metal and O2 minus as the non-metal. So we do the crisscross and we get the formula here Mn2O4, but we can simplify this formula into this, which is more preferable. Okay, and another example here, we have Pb4 plus and CO3 2 minus, metal and non-metal respectively. So we put a charge of CO3 2 minus on Pb, okay, and we put the charge of Pb4 plus to CO3. So we get the ionic compound formula here. So we can also simplify this into this one. This is more preferred compound formula. So how we want to name the ionic compound after we find or get the formula? So the rules here, where the compounds are named from the individual ions where they came from, and name the cation followed by an ion, and then remove the words ions from each of the name. And the cationic use original name, while an ion has the suffix "ite" added to its elemental name. Example here, we have Na plus as the sodium ion and Cl minus as the chloride ion. So we combine these two atoms together, we get the ionic formula as NaCl. So how to name this? We remain the original name of the cationic, so we put here sodium, and the chloride also we put here chloride, and we remove the word ion. So the name for this compound is sodium chloride. So another example here, we have Fe3 plus, the transition metal, as iron 3 ion, and NO3 minus as the nitrate ion. So we combine these two, becoming Fe in bracket and O3 3. So the name of this compound is that iron 3, okay, because we have this 3 plus charge, okay, iron 3, and the nitrate also remain the same. Okay, we call this compound as iron 3 nitrate. We cannot change the nitrate into nitrite because it will form another formula where we have here FeN. Okay, this is what we call as iron nitrite. So in this case, this is the name for this compound. There are also common naming practices that has been used. So here we have the element of CnPOSFCl minus, IOSOH minus, NCl minus. So here the name can be carbide, nitride, phosphide, oxide, sulfide, fluoride, chloride, iodide, hydroxide, and cyanide. So we also have to use prefix or suffix. Okay, prefix, in this case we have 8 as the suffix, so a common form containing oxygen. Normally we have here 3 or 4 oxygen atoms. For example, we have chlorate ClO3 minus, nitrate and O3 minus, and sulfate SO4 2 minus, and we have ite at the end of the name. So this one, because the compound having one less oxygen atom than the 8 form. So here we have chloride, okay, ClO2 minus, as compared to this one having less one oxygen atom. So sulfide SO3 2 minus, and nitrite NO2 minus. Then we have the prefix per and suffix 8. So here same charge but contains one more oxygen atom than the 8 form. So here we have perchlorate ClO4 minus, so we have extra one oxygen atom. Perbromate BrO4 minus, we have extra one oxygen atom. Okay, example here we have prefix hypo and suffix ite. So same charge but contains one less oxygen atom than the ite form. Okay, so here we have hypochlorite ClO minus, because there is less one oxygen atom than this ite form. Okay, so the same goes for hypobromite BrO minus. So thio, okay, thio here is replace an O with S. Example, we have a sulfate SO4 2 minus. Here SO4 2 minus, but when we remove one oxygen atom or replace with S, so becoming S2O3 2 minus, we call this as thiosulfate. Okay, the same goes for sulfide, where the original name is SO3 2 minus. Okay, the formula. Then we replace one of the oxygen atom with S atom, so we get the formula S2O2 2 minus, so we call this as thiosulfide. So how we name the covalent compounds, there are criteria that we need to follow, and the first element here we have to use the original name, and we also need to add prefix if the element is more than one. For the second element, we have to add suffix "ide" at the end of the name, and in this case also for the second element we have to always add prefix. Okay, so for example here we have CO. Okay, the first element is carbon and the second element is oxide, so we put prefix here mono. Okay, since we have one atom of oxygen, we put monoxide, so we combine the words monoxide to monoxide. So here we have P2O5, so the first element is P, phosphorus. Since we have two atoms of phosphorus, we have to add prefix di, so the name will become diphosphorus. So here we have oxide, oxygen, okay, but since we have 5 atoms of oxygen, so we put here pentoxide. So here we have the prefix of mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca, which represent the number of atoms. And tips is that do not write the vowel twice, so we have to remove the words O or A, okay, from monoxide becoming monoxide, from tetraoxide becoming tetroxide. So now I am going to show you how naming of acids can be done. Okay, for the first case here we have simple acid compounds with only 2 ions, so we have to add prefix hydro at the front of the name, and the suffix "ide" from the ion is replaced with "ide." Okay, so let's take a look at the example here. We have an ion Cl minus, and the anion name is chloride ionide here, and the symbol is HCl. So we put the prefix hydro at the front of the name, and the "ide" at the end is replaced with IC. So don't forget also to add the word acid at the end of the name, so the name will be hydrochloric acid. Second case is that complex acid compound which have oxygen atom in them. Okay, for an acid with polyatomic ions, the suffix "ate" from the ion is replaced with "I". So example here we have an ion NO3 minus. The name of this anion is nitrate ions, so 8. So the symbol is HNO3, and the acid name can be nitric acid, and don't forget the word acid at the end of the name, so the name of this acid will be nitric acid. So we continue naming of acids. For the third case here we have the polyatomic ions with 1 fewer oxygen atom than the 8 ions, so the suffix "ide" from the ion is replaced with O's. So example here we have NO2 minus, and the anion name is nitrite ion, so the symbol will be HNO2. So the acid name is nitrite replaced with nitrose, so we put acid at the end of the name. So the fourth case here we have ion with 2 fewer oxygen atoms than the 8 ions, so we have to add prefix hypo at the front of the name, and the suffix "ocil" from the ion is replaced with O's. Example here we have an O minus. Since we have less oxygen atom than this one, so the anion name will be nitrosyl ion, and the symbol is HNO. So the acid name will be hyponitrous acid. Okay, And the last one is the polyatomic ions with one more oxygen atom than the 8 ion. So the prefix per is remain, but the word oxy is removed, and the suffix 8 is replaced with I. Example here we have NO4 minus, we have extra 1 oxygen atom, so that is why the name we put extra oxy here, okay, peroxynitrate. And the acid symbol is HNO4, and the acid name will be pernitric acid. How about naming of bases? Okay, the rules here say that most common bases contain hydroxide ions, okay, or polyatomic ions. So therefore, either strong or weak bases are named following the rules for naming ionic compounds. Example here we have Na+, the cationic name is sodium, so the base here will be sodium hydroxide. Okay, the same goes for Ca, calcium hydroxide, and NH4 plus ammonium, we put the hydroxide ion, so the name will be ammonium hydroxide. So now we continue with naming of hydrates compounds, but first we have to understand what is meant by hydrates. Hydrates is actually a compounds that attract and bond with water molecules when they crystallize. So the hydrates are named based on the ionic compounds followed by the numerical prefix and the suffix hydrate. Okay, the symbol will be dot and H2O, okay, which indicates that N is the number of bonded water molecules. Example here we have the prefix mono, and the number of atom is 1, so the name will be monohydrate, and the symbol of the compound will be XY dot H2O. And for the di, tri, tetra, penta, hexa, hepta, octa, nona, and deca will follow the number of atoms here. And don't forget to put the hydrate, okay, at the end of the name, and the symbol following the number of atoms 2, 3 until 10.